Arithmetic sequences are sequences where the differences between consecutive terms are constant in a sequence. So, for example, if we have the sequence 1, 4, 7, 10, notice that all of these terms have this this common difference. The difference between the first and the second term is 3. The difference between the second and the third term is 3. And the difference between the third and the fourth term is 3. Now, if you look at this sequence, the difference between these two terms is minus 15. The difference between the second and the third term is negative 15. And then negative 15 again. So these two sequences, they have what are called common differences. So these things are called common differences. Common differences, and we denote the common difference as d. So we say that the common differences, we call them, we represent the common difference by the variable d. In general, we can write an arithmetic sequence as a, where a is the first term, and then a plus d, a plus 2d, a plus 3d, because we're just adding d to the previous term to get the current term, so, or to get the nth term. So a plus d would be the second term if a is the first term. A plus 2d is the third term, and then a plus 3d is the fourth term. So in problem 1, it says determine the explicit formula for the nth term of the sequence in the sequence below, and determine the 15th term. Whoops. So in order to do that, first let's figure out what the first term is. So the first term is 25, and let's look at the common differences. So here we're subtracting. This is the same as the sequence that was written above, but we have that the common difference is negative 15. Minus 15 and minus 15. And we have that because the differences between terms are constant, that this is going to be in terms of n. If we write this sequence in terms of n, it's going to be linear. It's going to be linear in n. So we'll have that t sub n is equal to minus 15 n. Actually, let's think about this a different way. Okay, so we know that this is going to be minus 15n if we looked at this in terms of, kind of how we looked at linear relations before. But let's think about this slightly differently. Let's think about writing let's think about this in terms of writing the nth term in terms of the first term. So here we've got 25, and then let's think about how many times we've added the common difference to the first term to get the nth term. So to get the second term, I have added negative 15 once to the first term. To get the third term, so this is when n is equal to 2. To get the third term, when n is equal to 3, I've added negative 15 2 times. To get the fourth term, when n is equal to 4, I'll have added negative 15 3 times. To get the fifth term, I'll have added negative 15 4 times. So it's always, I'll have added negative 15 one less than the term number. So if we think about this, we have t sub n is equal to 25 plus negative 15 times n minus 1, because I'm adding negative 15 one less than the term number to 25. I can simplify this equation, and I would have that this is the nth term is negative 15n plus 15 plus 25, so negative 15n plus 40. Okay, so the next part of this example is it wants us to calculate the 15th term. So we have that t sub 15 is going to be equivalent to negative 15 times 15, not n anymore, because we know n is going to be 15 for the 15th term. So negative 15 times 15 plus 40. And if we do that, we get that we have negative 15 times 15, which is negative 225. Negative 225 plus 40 is negative 185. So therefore, the 15th term is negative 185. Next, it says determine an explicit and recursive formula for the sequence below. And this is just a general arithmetic sequence where I just have a sequence in terms of the first term and here I've just added a common difference to the first term to get the next few terms. So let's look at this. D is our common difference and A is our first term. And let's think about this just like we did in the example above. If our first term has term number n is equal to 1, I've added D one time to get the second term. To get the third term, when n is equal to 3, I've added the common difference twice. When n is equal to 4, I've added the common difference 3 times. So again, we've added the common difference one less times than the term number. So if I wanted an explicit formula for this sequence, I could write this as t sub n is equal to A, where A is the first term of the sequence, plus n minus 1 times the common difference. And that's because to get to the nth term, I've added the common difference one less times than the term number. So this is the formula for the nth term. This is the explicit formula. Now, the recursive formula, if we think about this, t sub n is just going to be equal to the term before, which is t sub n minus 1, plus the common difference d. So I'm just going to add the common difference to the preceding term to get the nth term. In the next video, we'll look at a couple of problems where we solve problems relating to arithmetic sequences.